Shit, I was muted. All right. Welcome. Hello on a beautiful day where it's finally raining in Southeast Michigan. It's wonderful. Been waiting like 10 days. You probably heard me bitch about it pretty consistently. But thankfully now we're starting to get rain, so that's a good thing. So why are we gathered here today on this lovely day? We're gathered here because Starliner, they finally gave an update. So there are two updates. One is a media briefing that was facilitated by NASA. And that is kind of a call-in media teleconference. And also there is the NASA Boeing Crew Flight Test Astronaut News Conference from the International Space Station. For those who don't know, there is concerns with the thrust system because of a helium leak that was known to Boeing before they even launched. For all intents and purposes right now, until they can do safety checkouts and be completely sure about the status of the capsule, they are stuck on the International Space Station. Another massive failure, massive black eye to Boeing and its Starliner capsule. What's up, Stitch? So that's what we're going to go through. We're going to start with like I said, the news conference from the space station. I don't think to be honest, I don't think we're going to hear a ton from either. We're going to have to kind of read between the lines, but I don't think that we're going to hear anything from the news conference from the International Space Station. But we shall see. So we'll get started with this one, and then we will go to the media briefing.
And we're going to have a procedure for you. I think we know what's going on.
So this is flight ops at, I think this is Wallops, if I remember correctly. So is this Wallops, Virginia? Because it doesn't look like Houston. I'll actually skip ahead a little bit because... All right, there's where it actually starts. So we'll go on the 5-minute
mark. Okay, copy. That is good for today. So station, this is Houston. Are you ready for the event?
We are ready for the event.
NASA Communications, this is Mission Control Houston. Please call station for a voice check.
Station, this is Chelsea Bayarte with NASA Communications. How do you hear me?
Chelsea, we have you loud and clear. How about us?
Good morning. Thanks so much for taking the time to talk to us today. We have a really big group on our phone bridge eager to hear all about your mission. Reporters calling in, please go ahead and press *1 at this time to enter our question queue. In the meantime, Butch and Sunny, I'll toss it over to you for some opening remarks.
Okay, well, great, Chelsea. Thank you so much. It's welcome aboard the International Space Station first. It's a great place to be, a great place to live, a great place to work. As you can see, the American flag behind us, showing the pride in our nation and what we have been able to do to this point on this mission. I thought I would take a few minutes and talk about the first couple of days of the mission when we were in Starliner. So let's start there. Launch was spectacular. I mean, truly amazing. And then we got into our operational capabilities checks, and the spacecraft performed unbelievably well. We have these things called Hooper-Carper's rating scale, 1 to 10, 1 being the best, 10 being the worst. I've never given a 10 in all my flight test year, a 1 in all my flight test years on a Hooper-Carper rating scale for handling qualities, but I was tempted. That's how precise this spacecraft controlled in all aspects of the various tests we did. I won't go into those details of what the tests were, but it was truly amazing, the precision that this spacecraft held. And then we got into day two.
When it
The
worked.
start of day two, it was the same starting off. And then we did have some failures, as we're all aware. We had lost an RCS jet, and then we lost another one. And then you could tell the thrust, the control, the capability was degraded. The handling qualities were not the same. But thankfully, we had practiced and we had gotten certified for manual control. And so we took over manual control for over an hour on the V-bar, the axis where we actually rendezvous with the space station. And for over an hour while the teams on the ground did their troubleshooting. And we got a couple of jets back. And then from that point on, you could tell that the thrust was degraded. At the time, we didn't know why. Obviously, that since the failures had just happened, you could tell it was degraded, but it was still impressive. Let me give you an example. Coming into docking, those final 10 meters, we have a tolerance when we actually connect with the space station of 5 degrees in attitude and about 4 inches in position. And so Starliner came right down in automatic mode at this point and right down the middle, even with the degraded thrusters, which was truly impressive, knowing what we know now and not knowing what we knew, not knowing it then, but what we know now, truly impressive that even with degraded thrusters, the capability was there to actually dock that precise. And then, of course, we became Expedition 71 crew members. We're fully certified for all aspects of life aboard the space station here, whether it's spacewalks or operating the orbit arm or maintenance, which we've done a lot of. That's part of living here. You have to keep that space station going. And over to Sunny for some of those details.
Yeah, thanks, Butch. I'll just add a couple other things once we got onto the space station. We still had a lot of checks for Starliner, and those all went really well. One of them was practicing for safe haven to make sure that we had all the emergency equipment that's laid out that we need to have to get into our spacecraft and use it as a safe haven in case something happens to the International Space Station.
Special thanks to Stingy. What the hell? Got to give you more money. Yes. Yes, you do. No, you never have to give me money, but it is always appreciated. And I appreciate it. Member for 13 months. Holy hell. Damn. Always appreciated, Stinge. Thank you so much, man. Yeah, she is floating and she's got some wild hair. Not as wild as the Russian chick that I put in Discord, but yeah.
There was also a couple other tests with habitability to make sure that the spacecraft is ready to support 4 people. We grabbed a couple ISS crew members to come in there with us and go through all of the actions, and as well as checked out the ECLSS, the environmental control system, pretty thoroughly throughout all these tests. And it really worked very well. So we are really satisfied with putting more people in the spacecraft once we get back and we work through all the issues that we've found already. I'll just reiterate again, this is a test flight. We were expecting to find some things, and so we are finding stuff, and we're correcting it and making changes, making updates with our control team. Every day we had conferences to go over things that we found or we thought about or we might add for the next flight. Once we got onto the space station, beside for all the Starliner tests, we've been integrated right into Expedition 71, 71 plus as we call it, and we've been doing science for them, maintenance, some major maintenance that has been waiting for a little while, like stuff that's been on the books for a little bit. There's a urine processor pump that we took one good pump out and put into a good body, and it's called Franken pump. That's ready to go in case we have any problems with the urine processing system. Butch and I just did a moderate temperature loop, low temperature loop cooling refill for all the USOS modules. I got to do some gene sequencing. I think you got to do some other science experiments as well with a moon microscope that was 3D printed. So we've been thoroughly busy up here, integrated right into the crew. And every about once a week, we get to jump into Starliner and talk to our control team there and work through all the new nuances that they're working very hard on the ground to make sure that we will be able to come home before too long.
That is the most diplomatic way that I've ever heard someone say the shitstorm of problems. We've just been working through it every week. So there is some of course, if you scroll through Twitter and you try and get information about it, there's plenty of drama queens that are trying to talk about, they only have 40 days left of oxygen and they don't have enough food and all this bullshit. I mean, it's the International Space Station. They have plenty of oxygen. They have plenty of food. There's no worry there. There are redundancies in place for issues with food. And it's not out of the question for one of the launch providers to send up an additional payload. So I mean, they could foreseeably stay up there for a considerable amount of time. There's no risk to their life right now. There's no risk of running out of supplies. That's all very well kept by NASA for contingency for issues that do arise during spaceflight. They do a damn good job of keeping it stocked and keeping reasonable amounts of things available for them to survive. Now, as Brian says, now they're leaking helium is another story. I've heard some reports that it is unsafe and unstable for return at this juncture. I believe that more, but again, that isn't out of the question. They can stay there for a considerable amount of time. There can be a quote rescue mission. There can be shifts in schedule. So when we get to, God, I can't even remember what crew we're on. Got to look at my patch. Hang on. 9. That's what I thought. Sorry, I had to look at the patch wall. When we get to crew 9, they could reduce the crew to a 2-man crew, extend provisions, and bring Butch and Sonny home on the return of crew 9. Or they could extend the stay of some of the crew 8 astronauts and bring them home on crew 8. There are plenty of different shuffling. They're not stranded. I'm sure for the PR and for to shove it in their face, Elon would happily launch a Dragon to go up and rescue them. So this isn't a critical situation. It's a mild annoyance at best. Light Rain, sweet Jesus, she looks like Callie the Destroyer, the demon hairdo is terrifying. She just needs a belt of human skulls. Maybe. What's up, Gemstone? Nash should give them a station a little shove out a bit further. See how radiation works. Well, that's interesting. So, you've heard me talk about it before, probably, but so NASA has awarded the contract to Starship to deorbit station. There is one vehicle that is capable of lifting the orbit of. So, ISS is so big that the orbit degrades and it risks falling back towards Earth. So there's one vehicle, which is the Soyuz, that is capable of raising the orbital inclination of the space station currently. Dragon's not equipped for it. I don't know that Starliner ever was, but with their performance issues, definitely not a candidate for doing so now. And then we don't have any other crew capsules that are capable. Could something be engineered? Maybe, but it seems like NASA has abandoned the project. So in 2030, they're going to start bringing down the International Space Station with Starship. SpaceX was just recently awarded the contract to deorbit the International Space Station. Could Starship raise the orbital inclination of station? I think probably it would have those capabilities. But it seems like NASA has given up on the project. Of course, they are more interested in Lunar Gateway, And ISS has pretty much served its purpose at this point. It's been up there for a really long time. They've completed a ton of science, and we're really at our bounds of low Earth orbital sciences that we can accomplish that justify the cost of continuing the project. So they'll move towards things like Lunar Gateway. They'll move towards things that are Mars centric, kind of building out that. So there will be other space stations. There might even be a LEO station that is a much smaller volume and much easier to kind of deal with. So, but yeah, they got a jettison Starliner. Yeah, I mean, realistically, that will probably. I don't know how they're going to do that either. They'll probably just deorbit it and go through a proper deorbit process, and if it makes it, great. If not, then it will obviously burn up. But that's why the concern is there to not put astronauts on the vehicle. So
Over to you, Chelsea.
That sounds great. Thanks, Butch and Sunny. Let's jump into some questions. We're going to start with Bill Harwood with CBS News.
Butch, given what you just told us in your remarks, based on what you know today, how confident are you that the Starliner will get you home safely, given the known helium leaks and the earlier thruster issues? And as test pilots, are you satisfied you have a workable backup procedures in place if the normal deorbit plan cannot
Good
be
question.
executed for some reason? Thanks.
Yeah, thank you. That's a good question, Bill, obviously. Yes, I'll say yes to all of those questions. We're absolutely confident. We've already, as Sonny mentioned, for Safe Haven, we had that test, not just the test, but also to do it for real when we had that possible conjunction a few weeks ago. And we got in Starliner, we were ready to go. Everything's in place as far as what we know now. That is a good point. We are actually doing thruster testing as we speak at White Sands, New Mexico, going through that process, trying to replicate what we saw on that flight day 2 when we were rendezvousing, and we're going to learn from that, and we're going to incorporate new processes, new procedures that we will employ if necessary. So obviously, right now we are ready. We will be ready then, unless the data shows otherwise. But right now, based on what we know, we are absolutely ready.
Our next question is from Marcia Dunn with the Associated Press.
That is the most military yes man answer I've ever heard in my entire life. Like, yep, we're ready to go, even though we all know that's not accurate. And
Yes.
yeah, they are certainly doing. Oh, why did it start going? Anyways, they are doing. They're trying to replicate the failures at White Sands, which they have a test range. With the RCS, they're trying to both replicate the failures and look for workaround fixes. I don't think it's certified for return. I know they got in it. What he was speaking of is the Russians blew up a satellite allegedly, and it's when you have debris floating through space like that at high rates of speed, it can cause issues. And those different particles can have a large impact on the ability of the shielding and protection of the International Space Station. So in the event that there was something that was critical to the operation, they basically jump in their spacecrafts and get ready to depart if necessary. Again, that's a very emergency procedure where you'll take more risks, but take more risk with the abilities, but yeah. So how the hell do they get comms so clear when Discord has such a delay? We all talk all over each other. Wait, Discord just sucks. Yeah, Discord doesn't give a shit about their users or their technology. NASA pours billions into it. So That's why. That's why I stinge. Plus, this is dedicated. I mean, to Discord's defense, there are millions of users of the shit product, and the only two people on this loop are Butch Sunny and Mission Control. So,
Marcia, go ahead with your question.
I'm sorry. Do you have any qualms whatsoever about returning in the Starliner yourself? Why or why not?
You know, Marcia, we've been through a lot of simulations for this spacecraft to, go through all sorts of iterations of failures. And I think where we are right now and what we know right now and how the spacecraft flew as it was coming in to do the docking as Butch described, I feel confident that if we had to, if there was a problem with the International Space Station, we can get in our spacecraft and we can undock, talk to our team, and figure out the best way to come home. Like I said, we've practiced a lot. So I have a feeling, I have a real good feeling in my heart that the spacecraft will bring us home, no problem. But like Butch said, we're learning now to optimize our specific situation and make sure that we know everything about it. If we just came home, we'd lose the SM and then we wouldn't be able to go through all this testing and understand about our spacecraft. I envision that we'll still do testing when we undock and before we undock, actually first to open the helium valves. And then secondly, once we undock, to make sure everything is working correctly as it's planned from what they found out during the thruster testing. So I have confidence, Butch has confidence. We're here on the space station with our safe haven of Starliner.
And I will add this, that we were able to rendezvous and dock because of the team effort. Guys like Dean Lenort and our propulsion officer and Ed Van Sice, our flight director, and the team on the ground is working together. What we did, taking over manual control while they assessed the situation and coming to the conclusion that we could re-enable those RCS jets that had failed and then get us here safely. As I said, with the precision still there with some degraded thrusters. And we feel confident that this team will do the same on the way home.
Our next question will be from Ken Chang with the New York Times. Ken, I wanted to give you a little bit of a heads up that we might get a momentary loss of signal pretty soon, but if you want to go ahead with your question, and then we'll just repeat it if we have to.
ISS. Also, can you give us examples of what you might hear from the test at White Sands that would give you concerns about the safety of Starliner for coming back to Earth? Thank you.
Hey, Ken, it does look like we lost them there, so I'll have you repeat your question once they get back online. Should just be a couple more seconds.
That's a traditional loss of
I will
signal.
take this time to remind everybody that we will have another news conference, a longer one this time, with NASA and Boeing leadership later today. So be sure to tune in for that as well.
As they were talking about, that's common.
In the meantime, we'll wait for Butch and Sunny to come back to us from the space station. All right, Ken, do you want to repeat your question?
Sure. First, I was saying, I imagine you're not complaining that you got to spend a few extra weeks at ISS. And second, I was wondering, is there anything that would come out at test? Can you give examples of something that would come out at test at White Sands that would give you pause about the status of Starliner and that for it being able to take you home safely? Thank you.
Yeah, we are having a great time here on ISS. Butch and I have been up here before, and it feels like coming back home. It feels good to float around. It feels good to be in space and work up here with the International Space Station team. So, yeah, it's great to be up here. So I'm not complaining. Butch isn't complaining that we're here for a couple weeks, extra weeks. I mean, your question is full of speculation. I really don't know personally exactly what could come out of there that would give us a huge amount of pause. What we want to know is that the thrusters can perform. If whatever their percentage of thrust is, we can put it into a package that will get us a deorbit burn. That's the main purpose that we need the service module, to get us a good deorbit burn so that we can come back. Our OMAC thrusters, our bigger ones, we haven't really had a problem with them. So we are very confident in the deorbit burn capability with the number of OMACs that we have. It's just that attitude from the RCS thruster. So, with a little bit, if they are degraded, we'll find out if they really are degraded, what that combination is to get us the right attitude. And I think with the number of jets we have, we're probably going to find something really positive. So beyond guessing, I think that's as good as I'm going to give you as an answer.
Yeah, one other thing, that during the burn itself, once we get to the burn, we're pretty much home free as long as the OMACs continue to operate, and there's no reason they wouldn't, because the OMACs can maintain the attitude themselves during the burn. So that's another added feature that is in our favor.
We'll now go to Gina Sinceri with
Okay, so what that means in English is that they're confident in the thrusters, the main thrusters. So basically what you do is you drop off the International Space Station and you hit reverse. So you basically hit the reverse thrusters, hit the brakes, retrograde or retro rockets, and you want to bring the vehicle closer to Earth so Earth's gravity picks it up and pulls it in, essentially. So you want to break that orbital plane. That's easy. That's easy enough to do. It really is. It's just like hitting the brakes. The part that becomes an issue and could be a challenge is they have a very specific area where they need to land, and that's where your attitude adjustment comes. So that's your fine tuning. That's your track. That's where you're going to come in. And there's a lot of math and stuff that goes into that. But that's the part that's difficult. That's the part that is more critical to get right. And that's probably why it was authorized for emergency with the Russian satellite that blew up. Because I don't think there's any concern with them being able to get back to Earth. I think the concern is where and how confident are they in being able to set it down where it needs to be set down. Now, this can land on land or water. That's a big plus. So I can land just about anywhere. Obviously, there's concerns if you get off track and don't have thrusters. Then you have issues where, well, we can't land in the middle of New York City. That's going to kill people. We're going to hit buildings. It's going to damage the vehicle. So on and so forth. And basically, after you pick that trajectory and after you've re-entered, there's nothing you can do to change it. I mean, there can be slight adjustments, but once you've broken that plane, there's nothing you can do to fix that attitude adjustment. That's why it happens in space, where they can change it. So, what's up, Puffer? They're doomed. No endeavor that includes a butch has ever been successful. Possibly, but all right, we'll get back to it. There's only a
ABC
couple minutes
News.
left of this one. Then we'll go to the other.
What did this hurricane look like from the space station, and how are your homes doing down here? Is everyone okay? Lost power? Tell me about that.
Yes, the hurricane is quite impressive. And I don't think many people know this, but I actually took a picture of a storm that was off the west coast of Africa about a week and a half before the hurricane impacted. And I'm about 98% sure that was the one that became Beryl. 4 days later, it was hurricane strength. I took some video of it, set it down. I don't know if the Weather Channel showed it or not, but showed it. And it was, like I said, very impressive. We got some pictures a couple of days later. And as it was very fortunate, the hurricane did slow down in its intensity, as you know. And I think all of our families doing well. We've got down trees like most people, but thankfully we've got good church folks and good neighbors that are coming by and helping us out clean up.
Yeah, I'll add just an interesting aspect of it. When it was really strong, we were able to take pictures of the eye and actually see the definition of the eye. And Butch and I were up in the cupola the other day, right as it was getting ready to hit the Texas coast, and you could see it had dispersed. The clouds had dispersed, but it was still very circular and still very huge. So we know we were
You have a great
praying for our
attitude,
friends
Neil.
down there in Mission Control and all of our family and friends in the Houston area, hoping everybody will be okay. And yep, power is lost, trees are down, but we're a big team. Everybody pulls together in Texas.
That's right, Sunny. We're going to go now to Tom Costello. We don't have a lot of time left, but Tom, if you want to go ahead with your question, we'll make it a quick one.
Hey, so understanding and appreciating everything you've said about the performance of Starliner, it is still billions of dollars over budget, years behind schedule. It seems it's been snake bit at every turn. Are you confident in the performance of the ship for future missions as well?
Wow, great question. Why did NASA let that get through? Damn.
Yeah, that's a fair question. I can tell you that this is the world of test. This is a tough business that we're in. Human spaceflight is not easy in any regime. And there have been multiple issues with every spacecraft that's ever been designed. And that's the nature of what we do. That mantra you've heard, failure is not an option. That's why we are staying here now. We did have some degradation and our thrusters, and we know that. And that's why we're staying, because we're going to test it. That's what we do. That's what we do in this business. We're going to get the data that we need to help inform our decisions so we make the right decisions. And that's why we feel confident. We've got a history of doing that, going back decades in human spaceflight. And that gives us confidence now that it will continue. We are very close and friends with those that are making these decisions, and we trust them. We trust their integrity. We trust their technical acumen, and we trust that the tests that we're doing are the ones that we need to do to get the right answers, to give us the data that we need to come back.
Butch and Sunny, thanks so much for taking the time. We're excited to talk to you again shortly before you come home. Have a great.
All right, we'll skip the platitudes. So basically, I thought that was a good question. That's a fair question. They're way over budget. They still haven't been able to do anything. How many spacecrafts have failed during docking to the space station? So one very specific thing, like rockets are hard. Space is hard. It truly, truly is. But we've seen an incredible cascade of failures from a legacy manufacturer who has every resource in the world, every ability in the world. People want to work at Boeing. People want to be a part of this project, and they still cannot put together a worthwhile project. That's the scary part. That's the scary part, is with all of the backing, with all the financials, with everything, they're not successful. And then you have a company that is making you look like ass, specifically, and SpaceX. SpaceX is doing everything Boeing wishes they could. And it's link. What? Oh, you want a link? No, I don't want to give you a link. All right, give me a second, because Brian has to interrupt the show, like he's special or something. We know I can't type and talk. Hey, go boo. So that is the first portion. That is the Butch and Sunny on the International Space Station. I thought there were some good questions. This is the media briefing. This also took place today, this afternoon. We'll see if there's any additional information in this. I don't know who is actually on the call. I didn't get to watch it live. So this will be my first time watching it through as well. It just happened about an hour, 45 minutes, maybe before I started. It wrapped up. So, thanks a lot, Brian. Yeah, I agree. I'm gonna forget to let him in anyways. So. But yeah, so this is the media teleconference. So there'll be some additional information given, I'm sure, in this specific one.
How's it going?
Good afternoon, everyone. Thanks for joining us for this call today to update the status of NASA's Boeing Crew Flight Test mission to the International Space Station. I am Steve Seisloff for NASA Communications, and we are joined today by Steve Stitch, the manager of NASA's Commercial Crew Program, and Mark Nappy, Boeing's Vice President and Program Manager for the Boeing Commercial Crew Program. We're going to start with them in just a minute, but quick reminder to reporters to please hit *1 to get into the question queue. And after opening...
What's up, Bri?
Hello. This was what I was able to watch. I didn't bother watching Sunny and the other name of which I do not remember at this moment. Chip?
Butch, that's
Butch
it. And Sunny.
During the original live stream, but I saw this one and I started arguing with people frequently.
Yeah, we'll see. I mean, I'm very interested to see what they're gonna. I mean, they didn't bring out Bruno, so who's the head of the program, and usually he's damage control. So they must either think it's not that bad or bad enough where
this is gonna make you think something else.
Really? Okay.
Oh yeah, it's bad.
Okay. Gotcha. All right. I'm looking forward to it then. We'll get going with it.
Remarks from Steve and Mark. We will move on then to questions from the media. So we'll go now to Steve Stitch. Go ahead, Steve.
Yeah, thanks, Steve, and thanks to all of you for joining in today. I appreciate your interest in the Commercial Crew Program and our crewed flight test. I'm happy to be here today. Special thoughts and prayers to those in the Houston area following Hurricane Beryl that made its announced arrival a little earlier this week. We know there's a lot of people that have damage to their homes, and we're without power in the Houston area. I'm one of those. So keep them in your prayers, and it'll be a long road ahead over the next few weeks. We had hoped to do a camera interview today, do the briefing via camera, but unfortunately, today is the first day that the Johnson Space Center is now back open, fully open for business. There's repairs going on across the center, and we just could not have enough people in place to support that. So hopefully the next time we'll get the right group together and we can do a camera interview or a camera media telecon. I'm supporting from my office. Mark Nappy's with us from Florida. We look forward to telling you a little bit about what's going on today. I know many of you had the opportunity earlier to listen to Butch and Sunny and ask them a few questions to talk about how the flight test has been going so far. And so I'm glad that you were able to talk to them and get firsthand their view on the crewed flight test and how great the mission's going. We're taking our time on the ground to go through
it's going so great.
All the data that we have before we decide on the return opportunity. We're taking time to build confidence in the spacecraft, to understand the thruster performance, those aft thrusters that failed off during docking, and also totally understand the helium margins before we undock. What we're doing is not unusual for a new spacecraft. I think Ken Bowersox put it very well last time we talked, that now that we have ISS and the ability to power a spacecraft from ISS, we have a nice opportunity to almost use the International Space Station as a temporary hangar to take our time and understand the spacecraft before we undock and return. We don't have a lot of big news to talk about today, but we wanted to spend a little time to update you on the testing and the work that's going on. The team's doing a great job working through the testing at White Sands, which I'll talk about, and Mark will as well, and then on the helium leaks as well. And a little bit of a hiccup, I would say, with the Hurricane Beryl coming through. Some people are actually impacted and not able to work as much as we would hope, but we're still continuing to make a lot of progress. Since we last talked at the White Sands Test Facility in Las Cruces, New Mexico, we have started the ground hot fire testing that we talked about. We put the thruster in the chamber on July 3rd and actually did an acceptance set of tests with that thruster. It's just to verify that that thruster is healthy before we put it through the performance that we needed to understand the flight performance of that particular thruster. It passed all its checkouts, and then so we've started through the profile we talked about last time. And so what we really want to do is we picked one of the thrusters which had a little bit of the low end of the thrust. It was around 80% or so thrust. We are going to replicate what that thruster saw to the best of our ability for the uphill part of the mission. So on flight day 1, there was some crew maneuvering that was happening with that thruster, and then on the rendezvous day, there was some pulses that happened as part of the normal rendezvous sequence. We're going to take that thruster and try to replicate that sequence as best we can. So we've tried to replicate a lot of the thermal aspects. In other words, what that thruster saw going into the rendezvous day. We point the solar rays at the sun before that. We try to add some heaters to the thruster to simulate that. And so right now that thruster has been through all the uphill phases of the flight, and we're now in the process of looking at all that data before we move to the downhill portion. The temperatures we've been able to achieve are not quite what we would have hoped for. Based on the flight data, we know in what's called the injector, which is where the propellants mix, what the temperatures were. So we're probably a little on the low side. The teams are off looking at that data and trying to discern.
Of course you're off on the low side because you don't have fucking proper cooling from the helium. That was the whole manifold issue. That was the entire issue. No shit. You would have to choke the helium
where
to get proper test results. What's that?
Where are they talking about the cooling? Is it right at the injector port?
So it kind of envelops it. So think of do you know how a car engine is? You have spark plugs and injectors.
Yeah.
And you have the manifold that kind of wraps around them so they screw into the manifold essentially. It's a very similar process with these RCS thrusters. So very similar.
So without that, then you wouldn't be cooling the engine at all, pretty much, is what you're saying?
Correct. Right.
The bell, obviously, that's bell's the bell, but the engine itself is liquid cooled by helium.
Well, you don't have bells because these are RCS. These are not rocket engines. So these are not traditional rocket engines. These are going to be your RCS or reaction control system thrusters. So you'll have the Super Dracos are actually embedded into, so the hypergolics produce thrust, and the design, the actual aerodynamic design utilizes the thrust parameters. But I can see if I can find a Boeing, but you're not going to have a traditional engine bell like you're thinking, or like at least I think you're thinking.
That's what I am thinking. You're correct.
CST 100. Let's see if they have a. Because I don't know. Yeah. Mod pitch yaws. LS rolls. Trying to find the correct one. So here are your roll thrusters. So those are your pitch and roll. If you look at the way that it came in, there was a lot of spin to it, and I think they spin stabilized it because they didn't have these directional thrusters. So instead of they basically induced a spin to turn the vehicle. So
they were a
kind of
bullet.
like exactly kind of like a roll program on a traditional rocket. So you have a roll program so you can stabilize it and not have to use as much thrust on the front side of the engine. So like top of the spacecraft, so you can save some of those either cold gas or hypergolic thrusters. So it's almost like they induced a roll with these LAS thrusters But the ones that we're looking at that failed are these LAS pitch yaw thrusters. So that's what these are down here. Do you see what I'm talking about? They're kind of built into the vehicle.
Yeah,
I assume you can see my mouse, right?
I can, yes.
Okay. So these are your pitch yaw. So these are for adjustment of attitude. And there are 12 thrusters. And 5 of those failed. I don't have a complete map. Boeing never released a complete map of which ones failed, but these are the ones that adjust your attitude. And I think that's why they use these rolls to try and roll it into place, essentially. So to try to spin it.
So can they use that spin to try to get entry? Is what seems like they might try to do.
It wasn't terribly successful. So it wasn't incredibly successful, and that's why they had to hold outside the sphere, and re-engage some of the thrusters. Now these ones, the good thing is these LAS escape thrusters, these work still, allegedly. So we still think these LAS thrusters on the escape side, so these 4 that are more traditional rocket engines, or closer to, these roll thrusters, most of them work, we think. We haven't heard any major issue with those. Here's your reaction control thrusters as well. But these are the LAS pitch yaw thrusters are the ones that had failures. 5 of 12 of these, and these are the most critical for attitude adjustment. So for your targeting. So like I said, no problem with them returning to Earth. You basically hit the brakes. You go retro with these LAS escape thrusters. You bring it back in. It gets sucked in by gravity. You stop with the escape velocity needed to leave, or fall on that horizon, which basically what orbit is, and you come back to Earth. Now, that's the easy part. The hard part is that very technical. We need to land in a very specific spot, and that is controlled by these LAS pitch yaw thrusters.
Gotcha.
Almost primarily. And they did not get good response from any numbers that I saw from the LAS roll. I mean, they were in the ballpark, but that's essentially why they had to stop, is because these were not sufficient to bring them into the situation that they needed to be.
So plus, because they were trying to roll so much, could that have damaged those roll thrusters?
Could have, because they shouldn't be used for that. They're used for very, very small adjustments. Very small adjustments.
Short bursts, not
right.
Let's be the drill that pierces the heavens.
Exactly. So we're talking about just short incremental bursts. You also have to think, and I don't know what their fuel situation looks like, but again, most of these engines are designed for short bursts. They're not designed for continuous running. They're not designed to fix or change or heal or do any of these issues. They're and space is always a game of how much weight you have on the vehicle versus so there's a balance between weight and use. So you're not going to take extra fuel. So you take enough fuel for the mission because fuel is heavy, especially hypergolics. You have 2-part hypergolics. I'm sure you know, they don't require an ignition source. Once they're mixed, they produce thrust.
And they have to stay liquid, right? So that's why you have to have them under pressure.
Correct. They have to stay liquid. And so
that's one argument I won. No.
Yeah. So they which is fine in space because space is very cold. So you can stay liquid. They're higher temperature. I don't know what Boeing uses hypergolic fuel wise. I don't know a lot about CST 100, to be honest. Specifically.
It's not the normal stuff. I know that. It's a weird acronym of 2 things that I don't understand. So
Let me see. I don't know a ton about it, but I can look real quick.
It's not mixing oxygen with methane.
No, it is not. It is. These are very. This is why. This is why egress of, like when we're seeing the Dragon capsule come back. This is why they have to put the sniffers on the Bidens on before egress, because the hypergolics are incredibly dangerous, and they check for leaks. So
right.
So I'm trying to see what it's made out of, because hang on. Are the Boeing Starliner hypergolics. Microdine RS-88, blah, blah, blah. We know that. It doesn't actually say what.
Let's see.
It doesn't actually say what they use. So it's hydrazine. The most typical I know are hydrazine. I think it's monoethyl hydrazine and unsymmetrical dimethyl hydrazine. I can never say that, but
NMH NTO system maybe.
Yeah, and aerozine is the other side of that equation. So it's one of those. It's some form of hydrazine with an aerozine. So UDMH, basically, is unsymmetrical dimethyl hydrazine. Hey, I said it. UDMH. So N2H4 is, yeah. N2H4 is hydrazine, just the base hydrazine. So that gives you an idea of what. And then I have no clue what aerozine is because I'm not a chemist, but I don't know. But there's different stuff like dinitrogen tetroxide.
Atrazine?
Atrazine.
No, absolutely not. That would never be used. It's a fertilizer.
Oh, okay. I know they use nitrogen tet or dinitrogen tet. God, this is why I'm not a chemist. Tetroxide. But I know hydrazine is one of that. And then I believe the Russians are using still dinitrogen that word.
Tetroxide.
There you go. Thank
Dinitrogen tetroxide.
There you go.
Hydrazine, just easy nitrogen compound. Yeah.
Yeah. So, but I'm pretty sure that the Soviets still use, or the Russians still use nitrogen tet or dinitrogen tet. So, this isn't reassuring. It wasn't supposed to be. I thought they were only allowed to stay up there for a month or two. No, I mean, the mission was a much shorter profile, but again, they're not in any danger of extending that mission time. They're certainly able. They're certainly up to the challenge, have the training, and the supplies are there. So there won't be any issue on that front. So
just send another Dragon up with food.
But I mean, basically, somebody's gonna have to send a cargo Dragon up, whether that's a Soyuz or a SpaceX Dragon or I don't know. I don't know anybody else.
Well, the Russians won't show up on other Soyuz, right?
The Russians are being really weird right now. which I completely understand. We're not going to get into the geopolitics picture, but yeah, the Russians are saying, "Nah, you kind of made your bed laying it," which is understandable. That would be the oddest thing in the history of mankind. The weapons that are blowing up our country, we're going to go save the company that's built those weapons.
Yeah.
I
Yes.
probably would tell the
Boeing.
Russians. Yeah, I would tell the Russians to screw, or if I was the Russians, I would tell Boeing to screw off too.
Come on,
honestly.
it's not Lockheed, okay?
Well, yeah, but I mean, Boeing makes a lot of things that go boom. So, but yeah,
What are the odds they can ride this back home, or is it just off the table now? Oh, you're gonna know in a few minutes here.
All right, we're gonna keep this going before we get too deep in the weeds.
Yeah.
Determine the next steps, and then the idea is to take that thruster and put it through the downhill phase of the flight. And the most stressing part for the aft thrusters, they are used not to execute the deorbit burn, but also they're used for attitude hold during the deorbit burn. And so we'll put that thruster through that, and we hope to get through all that testing this week or over the weekend. So that's going on at White Sands. And then really the purpose of that testing is to be able to look at the thruster. The thruster is instrumented. It has many temperature sensors on it, and to examine the thruster and just to make sure that there's no negative effects on the thruster from any of those pulses that it would have seen in flight. And it was chosen to be, this particular thruster that we're emulating was chosen because it perhaps saw the most stressing set of pulses for the flight. On the helium leak, we hope to bring that into the Starliner mission management team for final resolution later this week. The team has been working really hard on trying to understand that story, to double and triple check the margins related to the rest of the flight. And then a lot of testing has happened at the Marshall Space Flight Center, where we've taken a simulated, we talked about the flange leak on the P2D2 flange prior to the flight. We've taken a mock-up of that flange and put it through various stressing cases with lots of...
I'm going to look something up, so I'm going to go kind of quiet for a second. But I also want to reiterate, when we were independently watching this flight attempt to go up the time before it actually did. I believe I sent somebody a text message saying that they're fucked and they need to fix this before they ever think of flying, because it's going to come back to bite them in the ass.
And that person was me.
I think I sent that to somebody.
You said I was walking through Target.
I'm not entirely sure.
I believe his words were, "This is the most ghetto piece of shit I've ever seen."
Yes. Accurate though. So
yeah, accurate.
Very accurate. And here we are. So all right, I'm gonna continue. I'm gonna be quiet for like 3-5 minutes while I'm looking something up.
Heat simulating the pulses from thrusters. We've cycled that particular flange many different times with pressure cycles that we would have seen in flight, and even more. We've put seals in that testing that have had intentionally cut seals with imperfections, and we've really shown that the seal itself has been pretty robust in that testing. We've actually applied different amounts of grease and done all kinds of testing, and then also at the White Sands test facility, we've also been looking at Service Module 2, which was used for the first set of attempts for Orbit Flight Test 2, and tried to understand the potential leaks on that vehicle. And that vehicle has been exposed to hyperguls for extremely long. It's almost been wetted in some form or fashion for 3 years, and try to characterize performance of that vehicle to give us a little bit more confidence on in-flight potential swelling from exposure to NTO. So we've talked about before, Starliner is
NTO is
go to
nitrogen
return in
trioxide.
emergency if the crew needed to return at any point in time. It's go for return for any kind of emergency on board station. We're going to work methodically through our process including a return flight readiness review with the agency before we give the go to proceed toward undocking and landing. This is a very standard process, which we use for all of our Dragon missions. We use that for Demo 2, and we use it for every single Dragon mission that we're going to go fly, including the one coming up. We will have, as part of our readiness for Crew 9 launch, we'll do a Crew 8 readiness return review as well as part of that. So happy to answer questions, and I'll turn it over to Mark Nappy next.
Good afternoon, everybody, and thanks for joining us. First, I'd like to thank NASA for the opportunity for the media event today with the crew. All work stopped today on our program, and the teams really enjoyed watching Butch and Sunny do the media event. It was very uplifting to hear what they had to say. I'll keep it short with my opening remarks and just talk a little bit about what we've been doing and some of the lessons learned so far. There were a number of specific actions that were identified from both the helium and the thrusters anomalies. It's just a little bit over 30 of them, of which more than half of them are closed at the moment. So
wow, 30 anomalies.
Some of these are items like the test that Steve mentioned. That is the biggest item to work off. But there's a lot of very minor types of closures where we're furnishing some artifacts from previous testing or model analysis or doing some analysis to anchor some of our engineering conclusions. So those are being worked off. All these items are scheduled to be completed by the end of next week. The engineering teams are meeting every day on these items. The chief engineers.
Okay, so yeah, so I had to do some maths. Based on the materials that they made their thruster out of, and based on the burn rate of hypergolics, I think they shrunk. I think they essentially melted their thrust capability, and that works out as to why they wouldn't be getting, why they'd be getting about 80% of the thrust. The math.
Is that because of the spiral?
I think it's because of this. I think it's because of the helium issue and not being able to cool those thrusters, and then they got into trouble, obviously, with the thrusters. So they overutilized them and essentially melted the interior of the thruster. So they essentially shrunk their thruster. So they're not going to have the same capability. It will continue to degrade with the helium leak without being able to radiatively cool the thruster. And you'll be able to continue to degrade that thruster over time. It concerns the hell out of me that they're not increasing the test capabilities to replicate that, because I'm pretty damn confident that's what just happened.
Well, I've got a problem with their way that they're doing it right now. As you're saying, it seems like they are actively going and pretending like the helium is working in their tests to make it so they don't get to the temperature problem.
Correct. That's what I'm saying. They're not, because they said, well, we didn't get to the temperatures that we'd like to, because you're still flowing radiative cooling. So you're still cooling these engines, and these engines essentially shrunk and probably degraded pretty heavily. You could have a very critical failure of a blowout with the obvious temperature differentials, the fact that you shut it down, then you tried to overload it. We know that they tried to overpress the helium during the launch attempts. I mean, the degradation in those thrusters could be literally a ticking time bomb. They keep talking about the seals are intact. I don't know how they know that, but if one of these were to fail in a critical state, they could essentially blow up the craft. And that doesn't even account for re-entry heating, because your thrusters are going to go through a whole new expansion contraction. Then you have leaks. Then you have hypergols that are leaking back into. I mean, you could have an uncontrolled hypergolic leak that would that would obviously cause thrust issues, and if not, spin it out of control, could explode the entire fucking capsule, essentially. If that
And
makes sense.
I've got a question. In terms of how the ship is cooled on the inside, what does that use?
Probably helium. They're probably utilizing the manifold helium. I know that so this just compounds it. So the reason why I stopped it here is because I'm listening, and you're talking about the faults, and they're just small faults. Well, that's great, but you had a cascade of small faults that led to this problem. And one of those issues that concerns me going forward is if you lost radiative cooling, you're entering re-entry, you're building up plasma outside the vehicle. One of your faults during your actual successful launch attempt was the coolant system for the astronauts. So you could literally
boil them on the inside.
Reintroduce that fault and cook astronauts in their spacesuits on the way back. And if you, it comes down to say, we have redundancy, so we can. It's fine that a radiative cooling system with helium doesn't work because we have the suit cooling system. Well, that failed on ascent. That failed, during your launch attempt. So now your original system failed, your redundant system failed, and that puts people in danger. So these cascading failures really do make a difference, because you're never supposed to be one minor issue from the health and safety of the astronauts, and we're two redundant systems into failing, and we're into where that is damaging or could impact the health and well-being of the astronauts, and Boeing shouldn't return the astronauts on this capsule. 100%.
They're gonna do it.
They're going to, and yeah, it's I don't know. It's I hope NASA steps in. But Boeing's their baby. So, Jacob, I'm all about a faux Boeing hate stream. There's no love lost for Boeing in my mind. I think they're setting back innovation in space travel considerably with this. Just, I don't know. This flight has been a comedy of errors, and it's going to end with the death of 2 astronauts, and that's going to set our space program back considerably. So, I can imagine a need for a rescue vehicle in the near future. I'm sure Elon already has a Dragon ready to go. Like, if he doesn't, he's going to pretty quickly.
He could probably have them back on Earth within 24 hours. 9 hours up, 30 minutes down.
Yeah. My niece works for Boeing. I started asking her about the guys, the Epsteins themselves. She cut me off. They totally whacked them. Yeah, no question. No question. And Butch and Sonny, like, I don't fault them at all. They're doing their job. They work their ass off to get to the point of astronaut and test pilot, and it's unfortunate that they're going to suffer the most because of this. So, and Boeing is not putting forward the necessary caution to be able to protect their lives, and that's frustrating. That's very frustrating. But we'll keep going.
On both the Boeing and the NASA side are engaged to make sure that everything's being addressed efficiently. And then we have mission management team meetings that are hearing the pertinent closure of these items several times a week. We've got program plans and schedules that are being published daily. on the progress so we can plan ahead and keep providing help where it's appropriate. An example of the hurricane barrel that came through, obviously unplanned, did impact the resources that we have at JSC and in Houston at the Boeing facility. So, with those resources not being available, we had to reprioritize some of that work and reorder it so that we could still try to stay on plan. In parallel, we've been also working on some additional items with respect to Starliner 1 hardware. We're doing testing and inspections of the service module for Starliner 1 on the doghouses and the helium system to see if we can't duplicate what we've seen in flight and see if it does exist on that service module. We're disassembling and inspecting all available service module doghouses that we have. That includes some that we have for future flights, and like Steve talked about, our service module 2 from OFT hardware. We've also been taking that apart and seeing if there's anything that we can learn from it. We knew that there'd be some learning from this flight test. We've learned a great deal from how the hardware works, how our processes work, and how we can improve the things that we've been doing, even to the extent of how we've been sharing information with the public through you. You've done a nice job of giving us feedback so that we can make adjustments for the future. All this learning has been pretty valuable, and we've made some adjustments, and we'll continue to make more. After we land, we'll do we call them post-test or hot wash, and we'll look at all the lessons learned and apply the corrections as necessary. Let's shift gears a little bit, talk a little.
Rescue from the space station would be easy, but what if the Starliner has to be rescued while detached? Need rendezvous capability. Yeah, so like I said, once you start that process, once they hit the retro rockets and get back into the gravity of Earth, there's no rescuing.
Yeah, they can't just rebound up into space again.
Especially with the thruster issues, and then you'd be putting on all kinds of that would be the worst case scenario. And I think that's
that's
why
the retrograde bounce.
Yeah,
I think it works. I think they break.
Yeah. I once they detach and once they start heading home, they're committed. They're on their way. I don't know, especially again when we're talking about how many issues there has been with the docking procedure and the testing, the leaks, the everything. I don't think they have the fuel capacity to be able to reintroduce it to an orbital inclination where they could be saved. So once they start their go, they're going to be coming home.
Right. They probably out 25%, if not less, helium left.
Yeah, and I don't know that ISS is going to give them any. I think that puts operational crews.
They had 30 anomalies, and only half of them are solved.
Right, half of them are resolved, and it's been sitting there for what are we, 40 days, 49 days?
We're at 36 days.
Okay.
34 days.
34 days. Okay. So, they've had a month to fix it. Again, with all the resources in the entire world. They also have NASA that are troubleshooting it. I know that they've hired private contractors as well outside of the Boeing umbrella. They obviously have QLA to lean back on, Lockheed. So there are no shortage of resources. There's just very little you can do in situ with the limited resources you have available. So they're going to have to find a fix away from. It's not like they can go out it's not a vehicle. You can't just take it to the repair shop or even repair it on your own. They can't switch out those RCS systems. So they're kind of they're kind of stuck with what they have, and I worry about the continued stress on those metal parts. So,
and considering the amount of stress they had already, literally from spinning themselves in a circle,
right,
for a long time.
Yeah, to try and fix the situation. So it's
worst case scenario,
a concerning situation.
If they have randomly one of their yaw boosters just go out during re-entry that was keeping them upright, if they go into a spin, like incredibly quick spin, how much G-force do you think they're going to feel at that moment? A lot.
Yeah, I mean, obviously it's going to be less outside when you're in ZOG, and microgravity outside of. But if they have to stabilize it for some reason to come back in because they're just that far off on attitude, then yeah, I mean you're talking about some significant forces on the human body. Like there are multiple ways that they could kill Butch and Sonny, multiple ways, and that's concern is there has to be a clear pathway forward, and I hope Boeing just bites it and lets SpaceX go bring him back, and then they can try and revamp or do whatever. So
yeah,
but this is the multiple failed test flights from Starliner over the process of its lifetime. There was supposed to be one test flight and then a demo flight, and we had several test flights. And this is a deeply flawed, deeply failed demo flight. So just wanted to show you. So this is this is Starliner right here. So this is kind of the size we're talking about.
Here at Marshall
probably
Space
don't
Flight.
walk around it. I don't want to hear myself talk, but I was trying to see if I could see RCS from here, and probably not going to be able to. So they're going to be on the bottom of those feet. But so this is Starliner. It even looks like hell, but
I wouldn't go in that if you paid me.
It wouldn't be my first choice as a ride to space. So, but all right.
A little bit how the team's doing. We talking to some of our young engineers. One of our engineers, Amy Decker, out of the chief engineer's office, and we talked to her about how she thought things were going, and she was really excited. And to take her quote, she said, "The extra data we're getting, being up here for a while,
Excited.
is awesome," and all in caps. She just is
awesome.
Engineers are just, when more time that you have to get more data, the more excited they get. So it was really nice to see that they're really engaged in these issues. They're really engaged in learning as much as they can for the spacecraft and moving
engaged in
forward.
saving their lives.
And bottom line is, as engineers, we test, we learn, we fix, and that's exactly what we're going through. We have a long history of doing safety and quality stand downs, and we had one here yesterday.
We normally test, learn, and then fix when it doesn't involve endangering human life, though.
Well, we fix it and not just launch with it.
Right.
We try to fix it in process by spinning our aircraft or spacecraft.
Yeah. I mean, usually we fix it before we put humans on board. Usually.
Unless they're like your
at
whistleblowers.
Florida site.
Right.
If they're whistleblowers, we just send them up there. Obviously, we either poison them, make them no longer exist while eating lunch, or send them into space, I guess.
Right. Speaking of Boeing, just to shit on them a little bit more. I don't know if you saw it, but the 737s, they grounded them because there is a significant issue with the emergency oxygen supply. So
not working. I heard about that one because
they'll have to be inspected. Yeah. So I mean, Boeing's just tired of winning. They're winning everywhere. So.
All they do is win.
And during that we had Scott Tingle and Mike Fink come in and talk to our team, and they expressed full confidence in our spacecraft and our team. And in fact, Mike emphasized the importance of how all the systems work together, and that's the kind of learning that we're getting out of this test flight. It's also was really good to hear from Butch and Sunny and how great the spacecraft operated. If you listened to their media event earlier, they talked about their confidence in our vehicle and our team and our training, and the willingness to get in that vehicle and come home at any time. So with that,
they live so far, so I think they're okay with it.
Thank you, Mark, and thank you, Steve. We're going to go to media questions. I did want to note one thing that we've been asked quite a bit about, and that is that we do anticipate another crew news conference with Butch and Sunny before they depart the space station. Words. So more details to come on that, but that is on our radar. So just wanted to note that for folks. Reminder to please hit *1 to get into the question queue. And our first question is going to go to Marcia Dunn from the Associated Press. Go ahead, Marcia.
Thank you. Hello. Based on what you both know today, when is the earliest the Starliner might come back? By the end of July, not until August? And what's the longest it could remain at the space station at this point? Thanks.
Yeah, Marcia, I'll take that. This is Steve. Yeah, the big driver obviously is the handover that we have coming up between Crew 8 and Crew 9, which is in mid-August. So, we'd have to back up. We haven't yet done that yet, but, obviously a few days before that launch opportunity, we would need to get Butch and Sunny home on Starliner. So that's kind of the back end. I think we're really working to try to follow the data and see when's the earliest we could target for undock and landing. I think some of the data suggests optimistically maybe it's by the end of July, but we'll just follow the data each step at a time, and then at the right time figure out when the right undock opportunity is.
They do have other access ports. I mean, it's ideal for rotations, and there would be all kinds of, again, headaches with that, but it's not.
Why would the ISS choose to risk other astronauts rather than just jettison this piece of garbage that they have stuck to it right now?
Oh, I would agree, and that might be the edict coming down from Boeing is somebody's gonna have to come save your ass, so we're gonna have to dump your spacecraft, and this is your hard deadline. I could certainly see that being. I could certainly see that being the case. I can tell you that NASA is less than pleased. Does that mean that they're gonna stop working with Boeing? No, of course not. I mean,
darn.
Legacy contractor, blah blah blah. But they are less than enthralled with the effort put forward by Boeing and Boeing Systems and CST 100. I don't know. I would assume, from what I've heard, that CST 100 will require another checkout flight before it is allowed to carry astronauts back to space.
You're talking about this one?
Yeah. I mean, the next iteration of the capsule, but that's the Starliner will have another uncrewed demonstration flight after this vehicle returns. Either way.
They bet.
So, yeah. So.
Oh, that's so bad.
Which they should. They should have to, certainly. So. But all right, we'll keep going.
Thank you. And next, we're going to Bill Harwood from CBS News. Go ahead, Bill.
I can figure out how to unmute this phone. Can y'all guys hear me?
Yep, we have you.
Oh, thanks. Well, just to follow up on Marcia's question, Steve, is there the only number we heard before launch was the time on the batteries. I'm just wondering, as this is day 35 today that you've been off the ground. I'm just wondering if whenever you choose to come home, whether it's end of August or whatever, end of July, whatever, Are any waivers required for that? Were there anything, written down before launch that said this is when you need to come home, and now you're going to change that, and you would have to do some kind of waiver? Thanks.
Yeah, thanks for your question, Bill. I mean, the biggest one really is the batteries. We had set the 45-day limit prior to launch, and that's the one that needs to be processed. As I talked last time, we know that the batteries are healthy on Starliner. They're not really showing any signs of any performance anomalies at all. So,
the solar's working.
The way the battery risk works is any day is the same amount of risk. So I think that's the main one. There's a few others we'll have to go look at relative to lifetime on a couple of handheld devices and batteries and so forth. But that's probably the biggest item that we've got to go work through. And the team's doing that right now to give us the margin we need.
Thank you. Next, we're going to go to Michael Sheets at CNBC.
Hi, everybody. I wanted to hear a little bit more about the white sands testing. As far as, testing the new thrusters, how is that different than the prior acceptance tests that were done on the thrusters in orbit? And why was the acceptance testing of the currently flying thrusters inadequate if you've had to change anything? And does this mean that there's going to be a redesign for the Starliner 1 thrusters, or what have you learned so far since the first test?
Fucking hope so.
Thanks.
Yeah, Steve, maybe I should start. First, this is not acceptance testing that we're doing with this thruster. This testing is trying to replicate what the worst case thruster saw in flight. So our call testing was sufficient for the thrusters. What Steve mentioned earlier is that so far we've not been able to replicate the temperatures that we saw in flight. So the team is off talking about that, matter of fact, right now, so that they can determine whether or not there's a form of testing that we want to go change, or something in the test that we want to go change so that we can replicate that situation. And then once we do, we will
stop flowing coolant through it.
I just poke a couple holes in your coolant line with a fucking needle. You'll be good.
Have a coolant fault. Only do your press at 20% coolant. There you go. There's your fix. Or increase the temperature. Or put it in a goddamn vacuum. I know you have a vacuum tester. I know you do. I've seen it. Put it in a vacuum. There's your heat. Right there. Jesus. We don't know. We're not sure how to do it. We're Boeing.
We don't know what we're doing here at NASA.
Jesus. Holy shit.
Go and run the downhill profile for the thrusters to see how that compares and how the thrusters operate. So now, does that mean that there's a change in the thruster itself? I would say no, and Steve can weigh in on this as well. What we're trying to learn here is, are there profiles, the way that we fly the flight, do we want to change that a little bit? Are there limits that we want to set differently in our software on how to deselect the thrusters? Those are the types of things that we want to learn. Over to you, Steve.
Yeah, thanks, Mark. I think Mark said it really well. Every thruster on the vehicle is acceptance tested, and so that is when the thruster comes from the manufacturer, it goes to White Sands and is checked, and so that's just a health status. It's fired for a number of specific pulses and durations, and that just checks that, makes sure that the thruster's working the way it is, it's producing the right thrust, using the amount of propellant it's supposed to use, and so forth. I think Mark said it really well. What we've found in this flight is we have fired the thrusters more than expected, and then I would say more frequently. And when I say frequently, I'm talking about how close you fire an individual thruster pulse to the next pulse of that thruster. And so what we're trying to do at White Sands is really replicate exactly what those pulses were that the thruster saw, and then understand the heating effects from those pulses, and just to make sure that there's no unintended consequences of those pulses. And as Mark said, I think there's ways now to what we've learned from this flight to change the
Well,
number
that
of
just means
pulses
that they're very
required for
short
the rendezvous and
pulses.
docking phase, and not put such demand on the thrusters. I think that's
Nearly
the work
none,
in front of
but,
us for
you know.
Starliner 1.
A molecule's width.
Yeah.
Thank you. Next, we're going to Joey Roulette from Reuters. Go ahead, Joey.
Hey, thanks. For Steve, I think earlier in the call you said during the hot fire testing on the ground, you've seen temperatures that are not quite what we hoped for. What do you mean by that? What is not what you hoped
Good
for? What were you
question.
hoping for? If you could just
What are you
spend
guys
some
talking
time
about,
going
you
into
idiots?
detail on that, that'd be great. And then Mark Nappy, when you guys are taking apart the service modules for the future Starliner spacecraft, what are you looking for? And based on what you know now, what changes do you expect to make to those service modules, and will that affect, readiness for the future, et cetera? Thank you.
Yeah, I'll start with the temperature part of the question, and then we'll let Mark answer that. What all the great work going on disassembly of the doghouses. We know from measurements on the thrusters, the 5 thrusters that the software deselected on docking day. We know what the thruster itself. There's what's called an injector temperature measurement, and that's what we are trying to replicate. And so that temperature was achieved by firing the thruster, and then also the fact that the thruster is located within the doghouses that we talk about, the port, the starboard, the top, and the bottom. And inside the doghouse, you can almost think of it as like it has insulation to keep the propellant lines warm during the dock phase, but it also kind of will retain heat. And so we did our best that we possibly could at White Sands by trying to mimic the effects of the doghouse in adjacent thruster firings by using heaters on the thruster. When we do that, for certain phases, we match pretty well. Other phases were a little bit low, on the order of 20 or 30 degrees low. And so we're trying to understand, before we get into the downhill phase, is there anything more we need to do to try to get the temperatures up a little higher during that final phase that we're simulating and replicating at White Sands for the dock phase, when we know the thrusters failed, were deselected by the software. And I'll let Mark answer the second question.
Okay, so this is in probably a couple of different answers, because what we're doing with the service modules is different for each type of vehicle. So for the service module that is going to fly on Starliner 1, that vehicle is already put together and the doghouses are installed on the service module. So what we're doing on that vehicle is running a series of leak checks to see if we can't determine whether or not it has the same susceptibility to a leak like we've seen on the current service module. So
Okay. I actually found this is Gemini, but this is very similar to what an RCS thruster looks like. So you can see that
it's tiny.
It's not a traditional rocket engine. So here's your hypergolics, save hypergolic flow on each side that comes into the pins. They mix in this chamber, and then it's just a straight exhaust. So there's no choke point. So you're not it's not the traditional thrust equation where you're moving hot gases through a smaller opening and then expanding those gases out. It's just the actual ignition of the gases provides the thrust. So I wanted to show you that. It's not the one they're using, but it's very similar. That's from the Gemini program. So
that testing's in work, and based on that testing and based on our determination of root cause in the future, we may have to take those doghouses off and take each thruster off and potentially replace some seals that we suspect might be undersized. So that's what is going ahead with service module. We call it service module 6 because that's the one that's being built for Starliner 1. For Starliner 2 and above, those doghouses were just delivered to us from our supplier, and they were planned to be disassembled so that we can take each thruster, send it out to White Sands, and have their normal ATP performed on them. So while we've been taking them apart, we've been taking a little bit of extra time to look at the interface of that flange area where we believe this helium leak is coming from, looking at those seals, making sure there's nothing in that interface that could cause the leak, and just collecting all that information so that we can plug that into potential testing that is currently be done at Marshall or that may be done in the future to determine root cause. And then the last one is Service Module 2, which I talked about earlier, that was used on OFT but did not fly. That vehicle was exposed to propellant. So we've got it out at White Sands and we're taking it apart real slowly and doing the same thing that we're doing on the future dog houses and doing the inspections of those flange areas to see if there's any anomalous conditions in there that could have potentially caused this type of leak. So all this information is going to go in a big bucket, and all the engineers are going to review it and try to see if it doesn't point to root cause or point to some additional testing that we can do in the future to eliminate this problem once and for all.
I would imagine that
Thank you, Mark.
It's not a
Our
critical
next
failure, you're
question
not going to
from
replicate
Micah
it.
Maidenberg at Wall Street Journal. Go ahead, Micah.
Hey, good afternoon. So Steve and Mark, we've been
Like if it's not a design failure or something that is a materials failure or something, it's very hard to replicate a failure when you're not using the same conditions. So I would imagine it would be very difficult to replicate a failure. May not be, but I think it would be pretty tough to replicate the exact failure in your very sterilized testing regimen, right? Like on your side, you don't get similar failures from complex molecules or whatever, right?
So in the world of resins, figuring out exactly what the problem was, unless it's like you just used some solvent and stripped off gelled up bullshit from the inside of the kettle. But like if it's like I can't tell like what exactly happened to this specific thing, why did it all crash out, stuff like that, you can't actually remake it unless you do it perfectly, and then it's also considered a critical failure at that point. It's easier to get critical failures, sure, because you don't have to like beat the thing with the damn hammer until it breaks. But it would be really difficult.
To replicate the exact failure, if they can replicate the exact failure, I guess is where I was going with that. If they can replicate the exact failure, then it is a critical system error that was a design flaw or some kind of significant flaw in the design and engineering process of the vehicle.
Yeah.
Like if it was just an anomaly and it happened, I think the probability is you're not going to replicate that failure.
Oh yeah.
So.
Oh yeah. Yeah, that'd be rough.
Yep. All right, we'll keep going.
going over the work on the thrusters and the helium leaks and how the team has been reacting to those issues. I guess my question is, at some point, do you have to potentially stop reacting to those, to those issues and shift to potentially using a different vehicle, for the return? I mean, is there some sort of preset trigger or red line that you would potentially cross that would sort of mandate or prompt such, that kind of a shift? Thanks.
I can start and then see what Mark has to add. I think the testing at White Sands is hugely important as part of that. Taking the data that we learned from White Sands and looking at the thruster and inspecting it physically, just to make sure that with all these pulses and all the heat we're putting into it, that it doesn't cause any damage to the thruster at all. The data from the flight suggests that the thrusters, except for the one thruster that did not recover, are operating just fine. I think that physical inspection is probably the most important thing that's going to happen over the next week or so. And then, after that, we've talked about the beautiful thing about Commercial Crew Program is that we have two vehicles, two different systems that we could use to return crew, and so we have a little bit more time to go through the data and then make a decision as to whether we need to do anything different. But the prime option today is to return Butch and Sonny on Starliner. Right now, we don't see any reason that that wouldn't be the case. Again, this white sands testing is probably one of the key things to look at the thrusters and make sure that we all the engineering data suggests that the thruster is performing well and has not sustained any damage in flight. In fact, the thrusters have been fired. Even the one thruster that was producing very low thrust, we're not going to use anymore. It was fired 270 times on docking day. One of the thrusters was fired under 450 times on docking day. And so I'll turn it over to Mark and see if he has anything to add.
I think where you kind of concluded there was where I'm at. Plans are to bring the crew home on Starliner. We see no reason why that should be changed. We've got good hardware. We're trying to add to the engineering database of, so that we can bring good flight rationale together to our senior mission management team and provide more information so that we can, again, fix these problems once and for all.
Thank you both. Next is going to be Chris Davenport at the Washington Post. Go ahead, Chris.
Thanks, Steve. Regarding the flight profile, I mean, the RCS thrusters were obviously very important for docking. We just heard Butch talk about how precise it had to be, but I just sort of wonder, how dependent are you on the RCSs for the return trip? I wonder if there's any way to characterize how much they'd be firing on the return as opposed to on the uphill portion of it, and what that difference is, especially if the overheating is an issue. Thanks.
The biggest, great question. The biggest demand for those aft thrusters for the remainder of the flight is at the deorbit burn time frame, and it's really not. Those thrusters aren't used to provide the thrust for the deorbit burn. Those are the OMACs. We'll fire 4 OMAC thrusters out of the 12 that we have. We know all 12 OMACs are working just fine. We know that the propellant feed system for all the OMACs are working just fine. But the biggest demand is several hundred pulses during that deorbit burn to maintain the OMACs fire to provide the delta V for the deorbit maneuver to bring the vehicle back into the atmosphere. And then the RCS thrusters fired associated with those OMAC firings to just hold the orientation of the spacecraft as that deorbit burn is executed. And so that's the biggest demand coming up for those thrusters.
So like I said earlier, we can get back. We just don't know where we're going to hit if we don't have those thrusters working properly.
You know what irritates me a little bit about these types of things?
What's that?
They'll go and use terms like delta V instead of just saying the acceleration.
Yeah, well, I mean, delta V is, one of those iconic terms, but yeah, I mean, just use plain language. I mean, change in acceleration. You can't say change in acceleration.
Well, change in speed, which is acceleration. Change in acceleration is a word that I don't know.
Yeah, I mean, I don't know. They seem more confident than they should. I know that for sure.
That's what I'm seriously thinking, that they're trying to just calm people down so that they can eject it secretly.
Maybe. You'd have to reshuffle though. But we'll keep going. We'll see if they say anything interesting.
Thank you. And next, Gina Sunseri at ABC News. Go ahead, Gina.
Yes. Moving on to when they undock, what tests do you have for the crew for Starliner on its flight home?
Go ahead, Mark.
So they're the nominal. There really are no tests that we have to run once we undock. We have a series of operational checkouts that we're currently going through to see whether or not we want to run those after we undock. But the majority of the work that has to be done after undocking is just nominal return.
And I would add to that, obviously the whole undock to landing and then recovery of Butch and Sunny are part of the test flight. So for this unique undock and deorbit landing sequence, the biggest change, obviously, from OFT2 was we have Butch and Sunny on board. So, I'm sure we'll learn a little bit about getting in the seats and the suits and all those sorts of things. But those are all nominally planned activities. There's no special test for those. And then, how the vehicle does relative to the heat load of the crew and comfort of the crew during deorbit landing. And then we'll have accelerometers on the seats to measure the acceleration during entry, the G loads, the G's at landing, and so forth as part of the test flight. Those are all, I would say key parts of the test flight. But other than a couple of maneuvers that Mark talked about, the OCCs, which we're debating whether to do or not, the rest of the flight is really learning our first landing with crew.
So there are test objectives. You just are going them.
And next we're going to Lauren Grush at Bloomberg. Go ahead, Lauren.
Jesus.
Hi, thank you so much. So I'm wondering if you were to bring Starliner home right now in case of that emergency you were talking about, what would the thruster profile look like without the white sands testing being done? And I know this requires speculation, but can you give us an example of what you might learn from that downhill phase of testing that would change that profile? Would you turn off certain thrusters? Would you somehow limit the pulsing? Just curious how different it would be from the emergency scenario now.
Steve, I'll try to give this a shot and see if you want to add something. So after undocking, if we were to have to do that today, we would just perform a nominal undocking and return. The thruster, the propulsion system is highly redundant on each other. So if there was an issue with any one of the thrusters, the redundancy would take over and bring us safely home. Again, what we're trying to do with this testing is fill in some gaps because what the concern is not concern, but what we're trying to do is understand if the thrusters are performing nominally, then we will be able to undock and just return nominally. If the thrusters were somehow damaged, then what would we do differently? We don't believe that we have damaged thrusters, but again, we want to fill in the blanks and run this test to assure ourselves of that.
Why do they continue to say they don't have damaged thrusters? So this is the only thing I can get is they don't have visual confirmation because they said that visual inspection takes place later. So they don't have visual confirmation. So if they can't see it physically, then it didn't happen.
Hear no evil, see no evil?
That's what I'm getting out of this. Like, this is insane.
Dude,
this is insane. You know that you have... Yeah, it's exactly head in the sand. Like, you know exactly what the issue is. You've already stated that there... I mean, you had 5 of 12 in ascent on these specific pitch raw RCS thrusters. You know that there's a significant issue with these thrusters, and you just keep trying to convince us all that there's not an issue. So that bothers me because there probably is an issue. And yeah.
There definitely is an issue. They definitely have some issues.
Well, yeah, I mean, I know that. You know that. But it's confusing.
I think they're trying to be purposely confusing because they basically said the same two different things out of each corner of their mouth that contradict each other, specifically to these questions.
Right. Same question or slightly different worded question. And they're trying to treat me like an
intellectual rigor.
I had to get that in again. Somewhere. Did you see that one?
No, I haven't. That was the funniest thing I've seen all day. That made my day.
That was from the the NATO summit. He also called. Well, I'll tell you. I'll send you a clip. But yeah, he legitimately called the Secretary General and
intellectual rigor.
Oh my God.
So
it's a person who rigs things, obviously. Come on.
Right.
Like a person taking a rope and trying to rig up a set of lights.
The second one's so much worse. So I'll send it to you. Yeah. I'll send it to you. But we'll keep going with this.
Yeah, I think Mark said it well. The only plan we would have right now is there's one thruster that was producing very low thrust that we would disable for the rest of the flight, and that's going to be the plan for the nominal end mission whenever we have the nominal.
The one that's not damaged.
And that's the plan.
Right.
For undock right now, that would be the B1A3 thruster. We would not have that thruster available, and with the OMAX system that we have in place for the deorbit burn, that should happen nominally. We have 12 good OMAX. And then based on the engineering data we've collected during the flight, we expect that the thrusters would perform just fine with the number of pulses that they have on them. We have run engineering analysis and simulations with many of those thrusters failed, just to understand what that would do to the deorbit burn. And the deorbit burn sequence is very robust to any kind of thruster failure. So even if some of those thrusters were to fail off like they did on docking, the deorbit burn would be successful and the entry would be nominal.
I'd add one more thing that probably should have mentioned in my answer is that, we do have a lot of confidence in the thrusters as they are today. If you remember, shortly after we docked, we did a docked hot fire test where we fired 4 of those thrusters, and they all came back to either a nominal or very near nominal performance. So that's what gives us a lot of confidence that we have a good set of thrusters right now. With the extra time, though, let's go run this test and let's go try to replicate what we saw in flight and assure ourselves of that.
Thank you. Next, Tom Costello at NBC News. Go ahead, Tom.
At least ask for thoughts and prayers.
Update.
Yeah, exactly.
Just essentially following up on everything you've just said and understanding your confidence right now in the thrusters, your confidence overall in the ship. Is there any concern that if you had a replication of the thruster issue again on reentry, that the ship would somehow not make its target landing spot in New Mexico?
Thank you.
Yeah, that's a great question. From the simulation data that I've seen, we could lose many of those thrusters, and I don't have it in front of me, so I would hate to say all, but we could lose many of those same thrusters on the deorbit burn phase, and the vehicle would be just fine. We would be able to execute the deorbit burn just fine. In fact, some of the modeling of that deorbit burn had some more extreme failures where we lost pieces of avionics that took down multiple thrusters, and we still had good control margin. The OMAX themselves are set up to actually help. They normally just fire, 4 of them fire for about 60 seconds in a steady state fashion, but they are also set up to actually turn on and off, if you will, to actually help control the vehicle. It's a great safety feature that Boeing has and a level of redundancy that Boeing has on Starliner. So really what we're doing is just taking the time to make sure that we have looked under every rock and every stone, and just to make sure that there's nothing else that would surprise us. I think that's probably the best way to describe what we're doing as we take the extra time. It's a test flight, and the first with crew, and we're just taking a little extra time to make sure that we understand everything before we commit to deorbit, and we have the time at station.
Okay, so what he just said is that it could come in. He did not say that they could land back in New Mexico. If you missed that out of his answer,
yeah, he did say it.
He could come back in, and I have said that since the beginning. Yes, they could come back to Earth. I don't see that as being a problem. The problem is going to be, where do they land? He also said,
if they land on Earth, if they land on like solid ground, it'll be like a rerun of the Chinese space shuttle that blows itself almost up.
Oh yeah, the one that bounced.
Yeah, the one that bounced off the damn ground.
Yeah. So your other thing is, okay, so he talks about the wonderful redundancies, the safety redundancies. Okay, again, it is no longer redundancy. You are on your last effort. So you're going to have to utilize that. Yeah, you're going to have to use those thrusters, your return thrusters, as your attitude control. And that means that that's no longer redundancy. That means that you're primary and you have no redundancy. So again, when we went up, we were 3 steps away from killing the astronauts. Now we're 1. And that's the problem, Boeing. That is the problem. You're not going to utilize certain thrusters, so that's gone. So now we're using these tertiary control systems, and that is the cause of concern. Is we're now 1 step away from costing the lives of astronauts, and that's my concern. So, the only remaining question is when. Well, apparently, sometime before. When did they say? Mid-August?
Yes,
About
they
2
have
weeks?
to be basically off by mid-August because they have to make
Right.
way for Dragon 9.
Right. So, it's a Band-Aid. It's absolutely a Band-Aid. But it's not even a Band-Aid. It's
The Band-Aids would fix it.
yeah,
maybe.
we're just gonna act like it's not there and rely on redundancy. Well, again, there are multiple failure points, and so this is my if yeah, I mean, obviously wouldn't be in this position, but you have 3 cycles of redundancy, and so your first cycle of redundancy is gone. Your second were gone, so now you're on your third. So what's the confidence in that third cycle of redundancy not failing if the first 2 failed getting to this point? So we're already to our third redundancy, and I don't have confidence that our third redundancy is so ironclad, especially down the engineering workload, where your third set of redundancy is not going to be as robust as your first, your primary, or your secondary redundancy.
It's like parachutes. Have you guys ever
Right.
seen like emergency chutes? Those things are fucking tiny.
They're a fucking bed sheet, like essentially, like a very
They're
small.
to keep
they're
you
more like a
alive, not to keep you
pillowcase.
safe.
Right. It's gonna hurt.
I'm afraid of them putting them into like a dryer cycle, just spin them around like freaking gellify their brains.
Well, then they'll cook on the way back because the cooling system won't work. So they'll be like scrambled eggs when they get home.
Ooh.
Yeah, scrambled Butch and Sunny. I wonder if they'll be sunny side up.
I
That's
was
a terrible
say
joke.
that. I
Stop
hate
it.
you.
Oh,
I'm gonna act
actually,
like I didn't
Steve,
say that.
that very question that the gentleman just asked is one of the actions, one of the 30 actions that I talked about earlier. And the team is working through that and getting ready to present that to us this week with the answer that we'd be safe to come home.
Thank you. And next, we're going to Kenneth Chang at the New York Times. Go ahead, Ken.
I sent you that video.
Hi, thank you. This is for Steve Stitch. I was wondering if you could sort of compare and contrast the current situation with Bunny and Butch and Starliner with that of Frank Rubio, who I think is fair to say really was stranded on ISS after the coolant leak on the Soyuz. And in that case, NASA clearly wasn't comfortable with him returning on the damaged Soyuz, even in an emergency. So I understand that the prime option right now is for them to come back on Starliner, but has there been any work looking at any backup option on Crew Dragon or whatnot? Thank you.
Yeah, that's a great question, and certainly that situation was a little different. We had that relative to the Soyuz, we knew that the coolant system on that service module part of the Soyuz had totally leaked out, and so there was a lot of concern about what happens when that service module cooling system is used to transfer heat from the descent module on Soyuz, and so the temperatures inside the Soyuz module would have gotten pretty warm for entry, and there was a lot of concern about not only the crew but also the avionics. And so, in that case, we decided to use Dragon as a contingency return option for Frank, and had it set up to if we needed to use it as a lifeboat. We had configuration of Frank in the middeck of Dragon. I mean, certainly we've dusted off a few of those things to look at relative to Starliner, just to be prepared in the event that we would have to use some of those kind of things. But
you already
again,
had
our
them.
prime option is to return Butch and Sunny on Starliner. We've declared Starliner safe to be an emergency return vehicle. In fact, we actually had the crew get in it a week or so ago when we had the breakup and power up Starliner in the event that they would have to depart station. So we're pretty far away from where we were with the Soyuz. You know, we just want to understand the thrusters a little bit more before we commit to the final undock and return.
Thank you. We're going to go to Jeff Faust from Space News. Go ahead, Jeff.
Thanks. You mentioned that the temperatures you've seen in the White Sands test weren't able to replicate what you saw on the actual spacecraft. Is there anything else in the test that you've seen so far that allows you to at least narrow down the fault tree of what's going on with the thrusters that might cause them to be deselected? Thanks.
Steve, I can start. I've been getting daily briefs from our team. You know, one of the key learnings I think that we've gotten out of this so far is the fact that we get a great deal of thermal kickback from the doghouse itself. And so not all the heat is coming, you know, directly from the thruster or through the injector of the thruster. We're getting quite a bit of heat soak from the doghouse. So that's good information to have as we move forward and determine what the future mission profiles are going to look like, how we put the tolerances in the software.
So that's pretty much the entire the shell of it, the doghouse. So the shell that houses the critical parts. So they're getting some kind of refractory heat, which.
Are you sure it's not from the lack of cooling?
Well, I was just going to say, if you had a lack of cooling, you would probably get refractory heat because you have a cooling system that is essentially a radiative cooling system. So, but I mean, I don't know. Maybe.
Depressing.
So it you know how it deselects these. It's good information. So I think that's a key learning so far. Over to you, Steve.
Yeah, I haven't seen anything else in the data so far that indicates any other learning. I think, you know, we tried to do our best to replicate that profile that you talked about, Mark, and then the doghouse effects. It's almost like, I think of it as almost like a thermos. The doghouse acts as a thermos and doesn't let heat out. And that's the part that's hard to replicate in the test chamber at White Sands. But other than that, I don't know if we've got into any of the inspections today, Mark, or not. So, but I don't think we've learned anything else.
Thank you. Next, going to Marina Corin from The Atlantic. Go ahead, Marina.
Hi, this question is for Steve. You've said multiple times now that Starliner could come home right now in an emergency situation, but is a return journey in a nominal situation directly contingent on the ground testing of thrusters that you're doing now? Have you decided that undocking before this testing is complete would be the wrong decision? Thanks.
That's a good question.
Really puts right under their ass, though.
The ground testing is important to us, and I think we'll have it wrapped up this week or over the weekend. I think we really wanted to get that testing completed and actually physically inspect the thruster before we committed to the nominal undocking. We really want to also put all the data together. I think one of the things that Mark and I maybe haven't done as good a job as we could explaining how much data is involved in putting together the final pieces of the flight rationale for both the helium system and the thrusters. You know, the Boeing team has done a great job at looking at all the thruster performance for the entire flight, and so that's a huge amount of data. Ran simulations, as I talked about, of looking at various potential thruster failures, modeling thruster failures for the deorbit burn and other parts of the undock to deorbit and landing scenario. So a huge amount of computer modeling that we want to put together and understand. We want to also step back and make sure that we're not missing some integrated effect between the helium leaks in several of the doghouses and the thrusters themselves. And so we want to take our time to go through that data and then make sure that we're not missing something there. So really, I think in addition to the thruster testing, what we're really doing is laying out each piece of the data. And Mark talked before about fault trees for each one, and just to make sure we're not missing anything before we commit to undock and landing.
Trees?
There's one more piece I'd add to that, Steve. I've talked about in the past
redundancy.
That this test is going to, depending on how much we accomplish in this test, I'll just throw a nominal thing out there. Maybe there's 10 things we wanted to learn from this test. If we learn 8 and there's 2 more we could learn by doing additional tests while docked with Starliner on ISS, we certainly want to take advantage of that. And you can't understand or you can't define what that additional testing might be until you finish the test on the ground. So from that standpoint, yes, I would like to finish the test on the ground to determine, is there something else we want to do in flight that's going to help us understand this problem so we can fix this problem once and for all.
Thank you. Next, we're going to Irene Klotz at Aviation Week. Go ahead, Irene.
Thanks, Steve. This is for either one of you. Butch this morning talked about the low thrust during docking, although obviously he was very complimentary of the system and how it ended up performing anyway. But I was wondering if you could just please clarify if that underperformance was due to the ongoing disabled E183 thruster or due to underperformance of the 4 that were recovered prior to docking, and if there's some way to quantify exactly what was the underperformance overall during docking. Thank you.
I can give that a shot first and see if Steve wants to add anything. So what Butch was talking about was that after the first time the thrusters were deselected, we brought them back online again, and he had manual control, and he could feel that the thrusters were not operating at 100%. And the reason what he was feeling was that because of the time that the thrusters had to recover and see that their thermal profiles came back down to normal, they did not operate at 100%. The heat was still there, so they did not operate at 100%. Once they cooled off, then they went back to operating close.
Yeah, it's almost like there's a coolant system problem.
Man, it's so strange. Frank, I'm just... wow.
I don't get it. So, like, if you don't cool the engines, they don't return to... And bullshit, they're not getting any error messages, but he can feel that the engines on the outside of the capsule are not returning to normal heat.
Oh yeah, he's definitely feeling the 20% less thrust.
I mean, you can be a great test pilot and you're not gonna feel that at all. You could be like, oh, I think it's like 19.5%. Like, come on.
Man,
and you're not getting any
3.4% under ratio that we need.
Yeah, and you're telling me you're not getting any anomaly sign or any kind of feedback at all? Like, that's I don't know why they're trying to hide so very much of this. Like, we all know there's a problem. Like, why are you trying to still trying to gaslight and hide stuff? I guess that's just the way the world is now, but whatever. So
close to nominal. So that was his answer this morning, was that he could feel that thruster not working at 100% and working at, say, 50 or 80%. That was something that he could detect when manually controlling the vehicle. Again, once we got on station and the thrusters were cooled down, we did the hot fire test on station, and they returned to nominal. So our working theory is the heat is what was affecting them from, first of all, being deselected, and second, operating at less than 100%. Our reentry profile is much less demanding, and if there is no damage to the thruster should perform nominally, and that's what gives us confidence in our flight rationale. Over to you, Steve.
I don't have anything to add, Mark. Thank you.
Thank you both. We're going to go to Stephen Clark at Ars Technica. Go ahead, Stephen.
Thanks, Steve. I think my question maybe for Mark Nappy, although Steve Stitch can hop in if he wants. On the helium leak, Mark, you mentioned one of the theories you may have is the seals may be undersized and could be contributing to the helium leak. And you're going to look at that on the doghouses on the service module for Starliner 1. What makes you think that is a hypothesis? And would that be because the seals that were delivered maybe didn't match your spec from the supplier, or is that a design issue? Thanks.
Yeah, good question. And I probably shouldn't have said undersized.
What up, Dance?
So when we were on the ground and we had the first leak in the system, we did take that doghouse off and we did bubble soak around the whole entire doghouse, all the flanges.
Jacob, I don't have that soundbite because I'm on Rumble Studios. I'll find it though and definitely throw it in for next time. But other proper issues with the hardware? Apparently, I don't know. Apparently, hang on. I'm typing. There shouldn't be any issues at all, ideally. And it certainly seems like it is without question that it is a hardware issue. This doesn't seem to be a software issue whatsoever. So,
right.
All the interfaces that were potential leak paths, and what we found was with the bubble leak soak is a leak at the flange area where the two propellant lines go through and the helium port goes through. So it's a pretty simple design to where there's just a hole with an O-ring around it, and obviously helium was getting out from that flange area and somehow getting around that O-ring. So the initial analysis of that said that the design should have been sufficient, but there's obviously something going on in that cavity that we don't understand, whether there was some kind of foreign object debris in there, or Steve talked a little bit earlier about excess grease being applied to that flange area, which has affected that sealing surface, or maybe that design is slightly marginal and just with excessive heating or again FOD or something, the helium is getting around that O-ring. So what we would like to do is we'd like to duplicate that design on the ground under a controlled test and see if we can't make it leak, and then experiment with some larger seals or maybe a different material seal that may not be as susceptible to degradation from the propellant, and see if we can't make this anomaly recreate and then put a new seal in and stop it.
Wait a minute. So they're talking about post getting the astronauts back, I assume, right? Is that what you took that as?
I'll be honest. I know it's not during.
Because again, you don't have a new design seal, so you can't just change it.
They're probably just planning on just popping it on and calling it a day, seeing how it goes.
You would have to disassemble the entire thruster. Like, you can't do that.
Unless they had some like really weird and cool like hot swap technology where you just pull it out, pop it back in, call it a good day. But they don't have that. This is Boeing.
Right. I mean, this is Boeing, so we don't have that ability. So I mean,
duct tape in another helium tank. If
Maybe.
there's helium that they can use somewhere on
the International Space Station? Just anywhere, just a tank of it somewhere. Could they fill it into their own ship?
They could. There is helium on ISS. They could. It's operationally, is ISS going to? Are they going to allow Boeing to do it?
What if they send up a Dragon with more?
Well, that would be the idea. So the capsule going up in August, late August. That would be the determinant factor. Is can they put it together so they could replenish that, so it didn't rely on an emergency situation with, because you don't want to fuck NASA's redundancies because Boeing can't fix their own. So again, it's that one point of failure. So you'd have to replenish that at some point.
Right.
So ideally, yeah, they could send up, increased helium or a helium tank on, and the decompressed storage on Dragon, and you could do it that way. But that would have to be something that would be communicated through NASA to SpaceX to carry up. So, but yeah, it's possible. It certainly is possible. So, all right, we'll continue.
Thank you. And next we're going to go to Will Robinson Smith at Spaceflight Now. Go ahead, Will.
Yeah, thank you, Steve. Question for Steve Stitch. You mentioned the probable undock and return is likely at the end of July now at this point, if all the tests continue to go well at White Sands. If more time is needed to comb through the data, though, from the thruster tests and the work being done on the helium leak, could a scenario be entertained sort of like where Crew 2 did not have a direct handover with Crew 3 and Crew 8 could undock from their current port and Crew 9 dock where they currently are to allow more time for Starliner to remain on station? Thanks.
Yeah, that's a great question, Will. We've talked a little bit about that. If we got to the point that we had gone through all the data for Starliner and we were confident that it was good to go to do the normal undock and normal deorbit and entry, I think that is an option we could entertain as long as we had confidence in the Starliner vehicle for nominal deorbit and return. We could talk about that. We've started looking at that a little bit. We haven't done that extensively. We prefer to do the direct handover like we have, but that is an option that we could entertain if we needed to.
Okay, thanks. Next, going to Sawyer Rosenstein at NASA Spaceflight. Go ahead, Sawyer.
Thank you so much for taking questions. In terms of crew resource availability, I know there were certain crew items that were removed to make room for the urine processing facility part that had to be added. With it going near that 45-day mark, how much is set aside for them in the capsule in terms of, clothes, personal items, et cetera? And how much of the stock of where the ISS is that kind of eating into, if any?
I'm not aware of any issues relative to clothing availability or food availability. We don't really have any issues relative to that for Butch and Sunny staying a little longer than planned. Obviously, Dana's not here today, but there's a pretty big resupply mission coming up around the early August timeframe. There's a Northrop Grumman flight that's a big resupply in August, so that will really replenish the space station at that point. So I'm not aware of any issues in that regard.
Well, that's helpful. They could throw helium on that flight then.
Thank you.
Yeah, they could.
Going next to Marcia Smith at Space Policy Online. Go ahead, Marcia.
Thanks so much. And getting back to that 45-day battery lifetime issue, I'm still trying to figure out how you went from pre-launch, where someone had decided that 45 days was the battery lifetime, and now post-launch, you're saying that any day is the same amount of risk. So could you just walk me through that as to how you changed your philosophy or your understanding of the batteries and their lifetime? And you said that there's no indication that there's a problem with the batteries. What kind of signals or symptoms are you looking for that would tell you there might be a problem?
Yeah, we had set a certain risk level relative for the batteries that was equivalent to about 45 days prior to the mission. What we've been doing is we can compare voltages from every single cell and every single battery. There's 12 total batteries. I think there's 512 cells per battery. We look at the individual cells and how they're performing relative to each other. And if a cell or even a submodule in the battery had lower voltages or lower output, that could be indicative of some kind of health issue relative to that particular part of the battery. And so we get all this data on the ground. We've been watching it for the entire flight. And so we don't really see any degradation in any of the cells. And so if the cells are healthy, essentially the risk level of having some imperfection in the cell is the same for those cells as it is in any of these cells, which are commonly used in electronics all across the country. So when we looked at that, essentially, if you don't see any signs that the battery is degrading or any of the cells are degrading, then your risk level for any given day is the same. Therefore, the next period of time would be the same risk as the current period of time. 45 more days would be about the same risk. So that's kind of how we got through that, by really looking at the health and performance of the batteries. And that's something we didn't know pre-flight, so that's why we couldn't just sort of extend the risk, if that makes sense.
Thank you. Next, going to Richard Trebu of the Orlando Sentinel. Go ahead, Richard.
Hi, thanks for taking the time to answer our questions. This delay in arriving home, I know that SpaceX Crew 10 was running concurrent with Starliner. I would like to know at what point you will make the call as to which of the two missions will target that February 2025 launch date, and or if you've already made that decision. Thanks.
It's going to be Crew 10.
I think Mark can add to what I'm going to say, but we've talked a lot about, hey, waiting till we get CFT, Butch and Sunny home on CFT, return the vehicle back, and then looking at the amount of work that it's going to take to get to the Starliner 1 mission, and we're double booked it with Crew 10. I think the longer we go, probably the more risk there is to that date in February. But we'll make the decision once the vehicle returns and we lay out the work. And I'll see if Mark has anything to add.
That's accurate. I'd say the two things. One is the cert process is continuing. There's plenty we can do without.
Of course it is. Hang on. Will Light Ray, in response to the question, they never went up alive in the first place, went towards aluminum foil covered temple. Possibly, Boeing could have just killed them on the ground as sacrifices to their whistleblower process, and then just launched them into space. But they did talk earlier from the ISS, so
AI. That's all AI.
But AI, it was a fake, very cheap fake, $499 fake. So.
CFT data. But once we land, there's a post-flight assessment that we need to do that feeds into our certification data. We have to understand our in-flight anomalies and get those semi-resolved before we get certified.
Not
and then
anomalies,
lastly,
they're failures.
we have to understand these helium leaks and get that fixed for Starliner 1. I would say that's probably the largest threat to to where we end up flying that Starliner 1 vehicle.
Thank you both. I'm going next to Jeff Brumfell from National Public Radio. Go ahead, Jeff.
Hi there. Thanks for doing this and taking all this extra time. So I sort of had two quick questions. One was in the presser earlier today, Butch sort of indicated that he manually piloted the Starliner to dock. I was wondering if it was necessary that he had to do that, or if it was planned, or as a result of the thruster failure, if he had to switch to manual.
No.
And my second question is, these dog houses, can
they weren't allowed
just
to
say,
keep out here without him taking pilot control.
Just a little more about them, and if you have to redesign them, how involved would that be, and how much might that delay future missions?
Let me start with the last part of that question first. We would not be redesigning the dog houses. How the thrusters attached to the doghouse on a flange area is where this seal is, and that is what we would be talking about doing some potential changes on just taking that before that flange is installed on the doghouse. We would put a new seal in there instead of the one that is currently planned to install. So for future vehicles, that's just part of the installation. For the current vehicle that is in build right now for Starliner 1, we would have to take the existing flanges or thrusters off, put new seals in, and then put the thruster back on again, which would be an impact, but I don't have an assessment of what that looks like just yet.
And I can answer the part about the manual flying. Butch did take over and do some manual flying during the rendezvous and approach. The actual final part of the approach for the actual docking event was done in auto. The flight computers did that. Butch did a great job. When we needed some manual flying, when we were hot firing the thrusters, as the thrusters failed off, then we would hot fire them to make sure the thruster was good and we could re-enable that. And he did a great job of some manual flying out on the approach axis out beyond the 250 meters or so. And he commented the vehicle flies great, flies just like the simulator. And from what I've known in the simulator, I'm sure that the vehicle flies great. So.
Right. Odd.
Thank you. Next, we're going over to Anthony Leone from Spectrum News. Go ahead, Anthony.
Hyperbolic, maybe.
Hello. Good afternoon, and thank you all for taking questions. My question is,
Jesus,
will we be getting any updates, immediate updates of the thruster test, and will they be appearing on the NASA blog, the Boeing blog, with these updated thruster tests? I'm sure we're all interested in it. And just the second part, I know that the ISS can hold up to 8 visiting vehicles. So is there a possibility that if that is the case, and there's currently about 6 vehicles, or I believe right now, could the Starliner be pushed to a different dock? And if that's the case, how long it would be expected to be there? Could it be 6, 7 months from now? Thank you.
Yeah, I'll take the last question first, and then we'll comment on the reporting on the thruster testing. Right now, we have two docking ports that can accommodate Starliner and Dragon. The forward port, Node 2 forward, and then Node 2 Zenith. Those are unique docking systems set up for those vehicles, and so those are the only 2 places that we could put Starliner and Dragons. The other, on the Russian system, they have a little different system that they dock the Progress and Soyuz to, so those aren't available. There's not a compatibility with those 2. And then obviously the Northrop Grumman Cygnus spacecraft has what's called a berthing interface, a common berthing mechanism. So it's grabbed with a space station robotic arm and then brought in close in some bolts drive to then mate those 2 surfaces together. So we really have to free up a port to do the rotation coming up, and so one of the 2 ports have to be freed up for that. And then we'll figure out the right way to communicate the testing results. We're discussing some blogs maybe later in the week, and then I suspect we'll get back together again, maybe in the next week or so, and do another one of these telecons to give you an updated status.
Thank you. Quick note, we have time for one more question. For those who have questions or follow-ups who have not had a chance to ask them, please reach out to us. We will get a response to you. But we do have some other items coming up, so we have time for one more question. That is Lucy Oberg from AFP. Go ahead, Lucy.
Hi, thank you very much. I just have 2 quick questions. My first question is for either one of you. If you're checking if the thrusters have sustained any damage from firing them more frequently than anticipated, are the results of these tests going to be applicable for the 5 thrusters that were deselected while docking, or potentially more of them? In other words, were all these thrusters fired more frequently, all of them, and so are you checking if all of them could have sustained damage or only 5? I'm also wondering why this more frequent firing was not seen or analyzed during the uncrewed test, if the thrusters weren't fired this way during the first test, why? And my second question is for Steve. I'm just wondering, were there talks of any kind with SpaceX to see if there would be a possibility to send a Dragon spacecraft in case needed for Butch and Sunny? Thank you.
That was a zinger.
Yeah, let me see if I got all the a lot of questions there. I'll see if I can touch on all of them. The first question was the white sands testing. Does that data help with all 5 thrusters that were deselected during the rendezvous and docking approach? And I would say yes. We tried to design that test based on what we thought was the worst thermally induced set of failures on that one thruster that we picked. So it helps us understand all 5 of them as we do the testing of white sands. The second question, I think, was why do we have more frequent thruster firings on this flight? Really, there was 2 reasons. One,
about 4 times.
We had more maneuvers. The crew did some manual maneuvers on the first day of the mission, and a few more, so that caused a few more thruster firings. And then there was a change made to protect part of the thruster. There's a part called a solenoid on the thruster that was some concern about being overheated. And so the software was designed to fire the thrusters more frequently, but in shorter pulses. I don't think we totally understood, perhaps pre-flight, what that meant in terms of heat pulses that went into the system and caused the thrusters to have the low thrust that Mark talked about. And then the final question was discussions with SpaceX about sending another Dragon. There's really been no discussion with sending another Dragon to rescue the Starliner crew.
Thank you, folks. That's going to wrap up our time today for this mission status briefing about NASA's Boeing Starliner pre-flight test to the International Space Station. As I mentioned, please reach out if you have if your question wasn't asked or if you have any follow-ups, and we'll get a response to you. In the meantime, you can also follow along on NASA's Commercial Crew blog.
Yeah, we don't want to hear your empty platitudes. I wonder what Boeing stock looks like.
That's a good question. Pull it up for us.
I'm about to. Actually, they're up. They're up.
Oh.
I don't know how to share without. Just making sure there's nothing on here. Yeah, it's fine. 183.73.
Up 0.27. How?
If we look at their 5 day, it's down.
5 days down.
A little bit. 6 months. It's
terrible.
And year to date, Yeah, that's down quite a bit.
27% a year to date. It's just terrible.
Yeah. Yeah, 27.2. So.
And you know what? Not surprised.
Well, there's a 520. It dropped 170. Damn, it dropped off. That's about the time that all this information started coming out.
The fact that they're all screwed up and everything's going bad.
Mm-hmm. It looks like it rebounded. I don't know if they halted trading or what the case was, but
they probably. I mean, it's pretty flat.
We also just donated a bunch more aircraft to everybody's favorite person, so that could have some impact on it too.
Hurrah!
But so that is the current update on the flight crew tests. We're truly hoping for the safe return of Sonny and Butch.
Pray for it.
Hoping,
yeah,
they're gonna need it. Yeah, for sure. I'm actually gonna end the poll, which never happens. Like that never happens. Will Starliner bring Butch and Sonny back to Earth alive? 70%, 72% of you say no, and 27% say yes. I'm hoping you're wrong, but based on what we heard today.
Based on what we heard today, what I'm thinking is it's going to be a bumpy ride. They might come back alive. Right. I think they're going to be maybe a little smart about how much helium they have left. It doesn't mean that's not going to all boil off in reentry because it's so fucking hot.
Right.
But I think they're going to get jostled a bit more than normal.
Yeah. Yeah. I think it's going to be a little shaky. I think that where they land is going to be a significant concern. Yeah, no problem, Shen. I love pissing on Boeing. Like, it's my favorite pastime at this point because it's so easy to do. But yeah, I think that it's going to be an interesting ride home, and we hope and think and pray for the safe return of these two very brave astronauts, and hope that Boeing doesn't set back the commercial space program 10 to 15 years in the process, because that'd be unfortunate. So
yeah.
Yep.
Yeah.
But I have to tinkle. So I'm gonna log off here and I'm gonna go tinkle. As always, thank everybody for watching. Hopefully you learned something today that beyond the fact that Boeing is just total garbage. Hopefully you actually learned something. But thanks, Brian, as always, for coming on.
Of course.
Ants got an invite and totally just ghosted me. Didn't even write another comment in chat. So fuck that guy.
Ghosted you real good.
Yeah. I was even going to compliment England on making it to the finals of their soccer balls or whatever on his behest, but screw that guy. Yeah, until next time, ladies and gentlemen, I hope everyone has a wonderful evening, and I will catch you all on the next one. Take care, everybody.